functions. Again, we can call this an equation instead of a function. And it's going to be setting it equal to 0 and solving it using whatever methods we can. We're going to review some factoring techniques with polynomials, which will be great fun. So here, what are the real or imaginary solutions of 4x cubed minus 6x squared equals 4x? This one we know how to do. How do we do it? Step 1 is get it set equal to 0. We get 4x cubed minus 6x squared minus 4x equals 0. This is a cubic polynomial. Can we do something to it so that we can think of it as take out an x? And we could factor out a 2x if we wanted. So we take 2x out, we get 2x squared minus 3x minus 2 equals 0. So we have a linear factor here. The 2x is a linear factor. Then we have 2x squared minus 3x minus 2. That is a quadratic factor. Here, we can use the zero product property. I have two things multiplied together, 2x and 2x squared minus 3x minus 2. If that product is 0, that means either 2x has to be 0, which confused some people on the test. If you get 2x equals 0, some people were saying no solution. If 2x is 0, what is x? 0. So x could be 0. Or, on the right-hand side, I need 2x squared minus 3x minus 2 to be 0. To figure this part out, we have to do everything that we were doing last chapter. How do we solve this? This is a quadratic. We can try factoring it. 2x minus 2, x minus 1. Does that work? If we FOIL it, we get 2x squared. Minus 2x minus 1x gives us negative 3x. Negative 1 times negative 1 gives us positive 1.
I said 2x minus 2.
You said 2x minus 2.
2x plus 1 x minus 2.
2x plus 1 and x minus 2.
Yeah.
7, 13.
That will give us minus 4x plus 1, which is 3x. It'll give us negative 2 here. It'll give us 2x squared.
That's nice.
Are we sure that one works?
Yep.
Okay. We know that has to equal 0. So we do the zero product property again. 2x plus 1 should be 0. So x could be negative 1/2. X minus 2 could be 0. So x could be 2. So what are my zeros? Negative 1/2, 0, and 2. Right, the zeros for this quadratic, negative 1/2 and 2, but the zeros for the problem that we started with, it's a third degree polynomial, it's cubic, so there should be 3 zeros. We found 1 here, we found 2 here. All 3 of those are the answer. This is taken from the book that you guys all have on your iPads. It's just a bunch of factoring techniques. We're very comfortable with this one. We should be very comfortable with this one. This one and this one are pretty similar. We're very comfortable with this one. We've done factoring by grouping. Factoring by grouping was part of the 4-step process for factoring a quadratic with a leading coefficient other than 1. This is the new one, the sum or difference of cubes. So here in a minute, we're going to have to reference those formulas to factor some things. So you guys have those now. They were in the book, now they're in your notes, 2 places for you to have them. What are the real or imaginary solutions of this equation? The first step is to get it set equal to 0. 2x cubed plus 54 equals 0. 2, so we factor out a 2, leaving me with what?
X cubed plus 27.
X cubed plus 27. That equals 0. This
Perfect cube.
is never going to be 0. The number 2 is obviously never going to be 0. It's always going to be 2. So we need to focus on this one. X cubed plus 27.
Is it
We're going to have 2 times x plus 3 times x squared minus 3x plus 9 equals 0. Using the formula from the previous page to factor a sum of perfect cubes. We have perfect cubes because the cube root of x cubed, hopefully we remember that that one's easy, that one's x. The cube root of 27, what number raised to the third power gives us 27, is 3. So this is a and this is b for the formula from the last page. And if we have a cubed plus b cubed, they tell us it factors as a plus b times a squared minus ab plus b squared. So now we have to figure this part out using the zero product property. X plus 3 could be 0, in which case x is negative 3. That's one of the zeros. We need to figure this part out now. What do? Just as a spoiler alert, this does not factor nicely. So if you have a quadratic that does not factor nicely, what could you do to try and get the zeros? If you try graphing it, you'll notice that the graph doesn't cross the x-axis. Meaning what? So if the graph doesn't cross the x-axis, there's no real solution. In my question, I'm asking for what are the real or imaginary. If I were not also asking for imaginary, if I were just asking for the real solutions, you'd be finished. X equals negative 3, it's the only real solution. But since I'm also asking for the imaginary ones, we have to figure out what they are. How can we figure out what the imaginary solutions of this quadratic are? The opposite of b, so positive 3 because b is negative 3, so the opposite is positive, plus or minus the square root of b squared minus 4ac all over 2a. That's going to be both imaginary solutions because we have plus or minus, so that represents two numbers. We have 3 plus or minus the square root of, what is that, 27? Negative 27?
Yeah.
All over 2. That's going to be the x. So that's 3 plus or minus what? How does square root of negative 27 simplify? 3i root 3 all over 2. So if we want to write that in a plus bi form, that's just 3 halves plus or minus 3 root 3 over 2 I. So we started with a cubic polynomial, so we knew there had to be 3 zeros. We have 1 real 0, 2 imaginary zeros, for a total of 3. Now the nice part is that imaginary zeros will always come in pairs like this because of the plus or minus. Okay? If you have an imaginary 0, its conjugate is always going to be a 0 as well. So we have 1, 2, 3. So we have 2x cubed minus 3x squared plus 2x plus 5 equals 0. And we want to use the calculator to find the real solutions. Anytime the question only asks for real solutions, you can use your calculator, find the real solutions, and you're done. Okay? The implication is usually when they're asking for the real solutions only, the real solutions are probably some decimal that would be difficult to figure out otherwise. Our 0 is negative, so x equals negative 0.842. How many imaginary zeros are there? So there are going to be 2 imaginary zeros and 1 real for a total of 3 zeros, which should be the case because it's a third degree polynomial. So as a test to see if people were listening to me a few minutes ago, we have two imaginary and one real here. Would it be possible in a cubic polynomial to have only two real solutions? Imaginary solutions always come in pairs. So you will always have an even number of imaginary solutions. 2, 4, 6, 8. You could have 0. So is it possible to have only two real solutions in a cubic? No, because if I have only two real solutions, that would mean I have to have one imaginary solution, which is not possible because imaginary solutions always come in pairs. That's the idea there. So this is a very interesting word problem. What are three consecutive even integers whose product is 4 times their sum? The first thing we have to do is come up with a way to have an equation that gives us an even number. We have to know it gives us an even number. What can we write down algebraically that is an unknown value, but we know that it will be even? We could say 2x, where we're going to assume that x is an integer. No decimals here. X is an integer, then 2x is going to be even. Right? 2 times 1 is 2, 2 times 2 is 4. So if you multiply an odd number by 2, it's even. If you multiply an even number by 2, it's even. So how do we write three consecutive even integers? We have 1 here. What would be the next even integer after 2x? 2x plus 2. What would be the next even integer after that? 2x plus 4. So now we have three consecutive even integers. Their product is 4 times their sum. What do we do about this?
6x plus
So
6.
2x plus 2x plus 2 plus 2x plus 4, which is 6x plus 6.
It's 6x plus 6.
The product of the three numbers is 4 times their sum. We have to do some foiling. We get 2x times, or do we have to do foiling? No, we don't. We're going to use our calculator to solve this, right? Yeah. So, what we can do, we can say 2x times 2x plus 2 times 2x plus 4 minus 4 times 6x plus 6 equals 0. You can plug this in the calculator just like that. When you plug it in, you're going to find that x could be 1, x could be -1, or x could be -3. If you plug all of those in, if I plug in 1, I get 2, 4, 6. And if you check this, the product is 4 times the sum. 2 times 4 times 6 is 48. 2 plus 4 plus 6 is 12, which is 48 is 4 times 12. So this one works. If I plug in -1, I get -2, 0, 2. The product here is 0. The sum here is also 0. And you could say that 0 is 4 times 0. The last one, if I plug in -3, I get -6, -4, -2. The product is -48. The sum is -12. So the product is 4 times the sum. 4 times -12 is -48. So we have three different things that we could have here. And so if this is all we have in the question, we don't know which of the three to pick. So we say any of these work. So now here, another word problem. Everybody do step 1 of solving a word problem, please. Okay. Bullet point 1. What is the formula for the volume of a rectangular prism? Mr. Adams. The volume is given length times width times height. Bullet point 2, what variable expressions represent the length, the height, and the width? Height equals x.
Width equals x plus 1, and length equals x plus 4.
Length equals x plus 4. Because they tell us the width is 1 foot longer than the height. The length is 4 feet longer than the height. So they don't tell us anything about the height, really. So we say that the height is going to be our x. The width we know is 1 foot longer. The length is 4 feet longer. So that's bullet point 2. Bullet point 3. What equation represents the volume of the plastic storage box? Volume is x times x plus 1 times x plus 4. And yeah, they tell us that the volume is 36. So with this, you guys would be able to, in your calculator, find out what value for the height gives you maximum volume. You'd graph that, you'd subtract the 36 over, then you'd graph it. Or no, they've given you the volume, so you'd be able to graph it and find out what the height is, right? You'd graph it and calculate the 0. So that's how you would do a problem like this. I do need to add one problem to the notes here, just so we can see how this works. If I have x to the 4th plus 13x squared plus 36 equals 0. That is a 4th degree polynomial, a quartic. But the idea here is that I could treat this as a quadratic, couldn't I? If I say that x squared is u, don't I have u squared plus 13u plus 36 is 0? And in the interest of time, I believe we're out of here in less than a minute. This would factor as u plus 4 times u plus 9. Which would be 0. Now the issue is you have to remember that you're worried about solving for x, not for u. So you have to rewrite this as x squared plus 4 times x squared plus 9 equals 0. You do 0 product property and you get that x is plus or minus 2i, x is plus or minus 3i, and you can see that we got 4 solutions. Plus or minus 2i is 2, plus or minus 3i is 2 for a total of 4, which matches up because it is a quartic.